Hi everyone, welcome to geometry class. In this short tutorial video, we're going to be talking about triangle proofs. So a triangle proof is where you were given two triangles and we're trying to prove if they are congruent to each other. In a proof, what we're going to be given is a couple of pieces of information about the two triangles, and that is our given. And with the given, and the information we can see on the figures between the two triangles, we're trying to get to a postulate that will prove that the two triangles are congruent. Now the postulates that prove two triangles are congruent, if you recall, are angle, side, angle, side, angle, angle, side, 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 and hypotenuse, leg. Once we've gotten to one of those postulates, we can stop, and that's proof enough that two triangles are congruent. So let's jump into our first proof. Okay, so let's take this proof for example. Our given is that segment AC is parallel to segment DE, and that point B is the midpoint of segment CE. So let's write down our first given. Number one, segment AC is parallel to segment DE. The reason I can write that down is that it's my given, and I'm going to go ahead and mark that on my paper, on the figure. Segment AC is parallel to segment DE. Okay, what I can logically draw from that given is that I have alternate interior angles that are congruent to each other. Now, there are actually two sets of alternate interior angles. I've chosen angle E and angle C, but I just as well could have chosen angle D and angle A. But for this example, I'll choose angle E and angle C. Those are our alternate interior angles cut by this transversal right here. And they're congruent because these two segments are parallel to each other. Okay, I'm going to go ahead and erase the marks I just marked down here. There we go. So I can say that angle E is congruent to angle C. And the reason I can say that is by the alternate interior angles theorem. I'm abbreviating that. So that was what I can draw from my first given. The second given is that point B is the midpoint of segment CE. So let's go ahead and mark that on our paper. A midpoint is going to cut a segment into two equal halves. So when point B cuts segment CE into two equal halves, I get half BE and half BC that are congruent to each other. So that is what I can logically draw as my next step, is that segment EB is congruent to segment BC. And the reason I can say that is because that is the definition of a midpoint. And I'm sorry, I forgot to write down that this was our given. Perfect. Okay. Number 5, I am done with my given, so now what I have to do is go look at the figure itself and see if I can draw any more information from what the picture tells me. Now, since segment DA and EC are intersecting segments, I can conclude that I have a pair of vertical angles right here. And of course, vertical angles are always congruent to each other, so I can say that angle EBD is congruent to angle ABC by the vertical angles theorem. Perfect. Okay, so let's check out our two triangles. If I start at point E here, I have an angle, then I can move down, I have a side, and then another angle that is congruent to the same angle, side, and angle of our second triangle. So I can conclude that triangle ABC is congruent to triangle DBE by the angle side angle postulate. Okay, fantastic. So if you haven't already, go ahead and copy this down in your notes and make sure that you are understanding why we can draw each step from each other. Okay, great. So we have two more triangles, and of course we have a given, two pieces of information again. So our first piece of information in the given is that segment PR is perpendicular to segment MN. And I can say that because it's my given, so I'm going to make note of that on my picture. Okay, now I wrote two perpendicular symbols because what we have now are two right angles. We have angle PRM, and it's congruent to angle PRN because two right angles are congruent to each other by the right angles congruence theorem. Okay, perfect. Step 3, I'm going to go back to my given. I have that point R is the midpoint of segment MN. Okay, and again, a midpoint is going to cut the segment into two equal halves. So MR now is congruent to RN. So step 3, that was my given. And step 4, I'm going to go ahead and write that down. Segment M R is congruent to RN. And again, that is the definition of a midpoint. Okay, and step 5. I'm done with my givens again, so let's look back at the picture and see if we can conclude anything else. So we have this segment PR, and it's shared by the two triangles. So that side by both triangles is going to be congruent to itself because it is the same segment for each triangle. So I can say that segment PR is congruent to segment PR, congruent, by the reflexive property of congruence. Okay, so let's look back at our picture. I'm going to say that that PR is congruent to itself. So if I were to connect all the congruent parts between both triangles, I'm going to start here, and I have a side angle in a side that's congruent to the same corresponding side angle in side of this second triangle. So I can conclude that triangle MRP is congruent to triangle NRP by side angle side. Okay, great. Let's look at our. Now some of y'all, we've done this in class before, but if you want to see it again, I'm going to go over it one more time. If you are comfortable with this proof, you can stop and continue practicing proofs on your own. If you're not, then go ahead and keep watching. So in this proof, again, we have a given. Let's start with our first given. Segment AB is parallel to segment CD. That's our given, and let's write that down on our figure. AB is parallel to CD. Before we go on to our next given, let's see what we can logically draw as a conclusion from this given. Since these two segments are parallel to each other and are cut by this transversal, AC, I can logically conclude that I have two alternate interior angles that are congruent to each other. So we have angle BAC, which is congruent to angle ACD. And we can conclude that because that is given in the alternate interior angles theorem. Okay, let's look at our next given. We were told that segment BC is parallel to segment AD, which is our given. And what we can logically draw from this, let's go back and look at our picture. I'm going to mark that on my paper. Remember, I'm going to use two arrows now to signify they're parallel to distinguish them from our first set of parallel segments. Okay, so again we have this transversal AC that is cutting through our two parallel segments, BC and AD. So we have another pair of alternate interior angles. We have BCA and CAD. And since the two segments, BC and AD, are parallel, the two alternate interior angles are congruent to each other. So we have angle BCA is congruent to angle DAC. Again, by the alternate interior angles theorem. Okay. Step 5. We're done with our givens, so let's look back at our picture. Between the two triangles, we have the shared side, segment AC. So we know that by the reflexive property of congruence, that segment AC is congruent to itself. So we can go ahead and write that down. Segment AC is congruent to itself, segment AC, by the reflexive property of congruence. So let's look back at our picture. If I were to connect all of the congruent pieces of our first triangle, I have an angle, side, and an angle that is congruent to the corresponding angle, side, and angle of my second triangle. Okay, so I can conclude that triangle ABC is congruent to triangle CDA by the angle, side, angle postulate. Great, guys. Okay, so go ahead and practice proofs on your own.